the fundamental theorem of algebra, whatever the highest power, the highest degree on your function, that's the number of roots that you're going to have. So in number 2, we have x cubed plus 3. It's a degree of 3. So, and number 2, x cubed, what I say?
X plus 3.
Oh, x cubed plus 8. So it has a degree of 3. So that means it has how many roots? 3. So we're going to factor it. We need to figure out, there's only 2 terms. So really our options are the difference of perfect squares, or the difference of 2 cubes, or the sum of 2 cubes. So looking at this, is x cubed, can we square root that? Is that a perfect square? No. So now we'll look at cubes. Is x cubed, can we cube root that? Yes. What's the cube root of x cubed? X. Can we cube root 8?
Yes.
All right, so those are both perfect cubes. So we're adding them together. So we're going to use the sum. So a cubed plus 3 cubed is our a and b. Our a is the cube root of our first term, and b is the cube root of our second term. So for number 2, we have x plus 2. And then our next parenthesis is going to be a quadratic. It's a squared minus ab plus b.
X squared. Yeah, how did you get that?
Use the formula for
Yeah,
sum. All right, so now that's what we had learned previously. Now we're going to take it one step further. We want to find the actual roots. So the fundamental theorem of algebra says that this has 3 roots. So those 3 roots can be a combination of real and imaginary roots. So if we set this equal to 0, we can find what makes this parenthesis 0, which is going to be 1 root. And we can find what makes this parenthesis equal to 0. Now this one is x squared, so how many roots is it going to have? 2. So setting this equal to 0, so x plus 2 equals 0, so x equals negative 2. So that's 1 root. That's a real root, right? Now here's a quadratic, so we're going to use the quadratic formula to find those 2 roots.
Plus minus I.
All right, so for this one, I'm going to do the work over on this side. So x squared minus 2x plus 4. So to use the quadratic formula, we need to know our a, b, and c. So our a is the term in front of our x squared, so that's 1. Our b is in front of our middle term. And then our b is our constant on the end. Oh. Alright, so then our c is 4. So using quadratic formula, and just to refresh, quadratic formula is negative b plus. So now we're just going to substitute in our a, b, and c into the formula. So we have negative 2 plus or minus negative 2 squared minus 4 times 1 times 4 all over 2 times 1. So now we need to simplify. So negative 2 is positive 2 plus or minus the square root negative 2 squared. Remember to square the negative, so it's positive 4. Minus 4 times 1 times 4 is 16. And then 2 times 1 is 2. So now we have 4 minus 16 inside our square root. And that's a negative 12 over 2. When we have a negative inside our square root, how do we deal with that? Now, the square root of 12, can that be simplified?
Nope.
All right, well, can we do the factor tree? All right, so I have two 2's. So 2 on the inside makes how many on the outside? Can I simplify? Does 2 go into 2? Does 2 go into 2? Alright, so that whole thing simplifies to 1 plus or minus I times the square root of 3. How many roots is this? 2, because I have 1. I have 1 plus I square root of 3, and then I have 1 minus I square root of 3. So those are the three roots. So this graph has 1 real root and then 2 imaginary roots, but 3 altogether. Did I put the answers up to check them? Okay, so let's do that. I don't remember if I even... Who were here yesterday? For number 7, it's create a flow chart or set of directions on how to find the zeros of a polynomial. So for those people who aren't here today, and for those people who weren't here yesterday, what would be the step-by-step process that you would tell them?
Give up right away.
Oh, like which one? Because there's like the ones that you had to set equal to 0.
Okay, so set it equal to 0, first thing, right? Make it.
Talking about a Honda.
But that was.
So you have behind this, right?
No, I was just laughing because he said if a 2-stroke motor can handle a weed eater, then it can handle a car.
All right, so set it equal to 0. So that you want everything on one side of the equal sign. Then what's the next step? What do we need to look at first? What does the fundamental theorem of algebra tell us? It tells us how many zeros, right? So the next thing would be to figure out how many zeros we're going to have, right?
Yep.
All right, so now the next thing, once we know how many zeros, what do we need to do?
Look for a factor common to all pairs.
Okay, see if you can take out a greatest common factor.
Use a quadratic binomial formula.
Good for reading now.
I am.
So look for a greatest common factor. Can you make it simpler on yourself? Can you take something out to make the factor? So now, once you've done that, then we're going to factor it, right? And so our options are, it's a quadratic, so we can use quadratic formula, or we can do cubed, right? Or we can do cubed, or we can do factor by grouping. Those are our options at this point, correct?
What part of it?
Once we have it factored, when we factor it, what do we found? Like after we factor it, then we need to find what makes the parentheses equal to 0, right? So this is where we'll use, the quadratic formula to find the zeros, or we'll set the parentheses equal to 0. and that's once we found the zeros, then it's factored. We know, what values we can stick into that quadratic or cubic to make it everything is zero. And what that tells us is, in our graph, where it's crossing that x-axis, which will be super helpful when it comes time to graphing by hand. All right, so let's look at example B. All right, so if a is a zero of a polynomial function, then x minus a is a factor of the polynomial. Find a polynomial function of third degree that has zeros at 0, 2, and -3. So yesterday we looked at finding the zeros. Here it's giving us the zeros. We know that x equals 0 at 0, that x equals 0 at 2, and x equals 0 at -3. All right, so these are our zeros, so this is what x equals at those points, right? So now to get from here to here, what did they do? Instead of x equaling 2, they moved the 2 over, right? So they made these so everything was on one side of equal sign. All right, so then, are we okay with this first step? All right, so now from the first step to the second step, it says multiply the binomials. So what did they do? They FOILed or plus. So they multiply these together. So x minus 2 times x plus 3 gets us this one here. Then from step 2 to step 3, what did they do? They distributed that x to each of the terms. So x times x squared is x cubed, x times x is x squared, x times -6 is -6x. Alright, so this is the polynomial. It has a degree of 3 with these 3 roots. Now, if it said find a 4th degree polynomial with these roots, would that be enough information? No, because that would give us, because this has a 3, and so if it was a 4th degree, we would need another root, right? Alright, so let's try one together. We'll follow their 3 steps. So find a polynomial function with the indicated degree in zeros. Do you want to do A or B?
C. Yeah, A.
Alright, so let's do A. So this tells us that our degree is 3, and then our zeros are at 0, 5, and -7.
Do we have to write the f of x? Like, is this like f of
Zach
x,
on
and then
potato?
it equals?
No, just at the end, write it. So here we know that x equal our x-intercepts are 0, 5, and -7.
It's not that bad.
A lot of you complain that this is hard, but you're not putting forth a whole lot of effort to work on it.
And then it'll be times x plus 5.
Alright, so this would be x plus 0, which we don't ever write the 0, right? No, so this was just our x. And then when we moved our 5 over,
X plus 7.
so now multiply the binomials. So let's multiply these.
X squared. 7x. -5x. And then -5. And then 5.
Alright, so now this x needs to be part of the fun.
X cubed.
so what function has a degree of 3 with these zeros? This polynomial function.
What's the end?
That's the degree. All right, so this next one, we have n equals 4. So that means that our highest degree is 4. And so, but it only have, I have 1 and 5. So how do I get my 4 roots from that? All right, so this means that we have x equals -1, x equals all right. May I erase this because I'm going to need a little more space. All right, so what are my parentheses here? All right, so now this next step was to do to multiply these together, right? So we're going to multiply these together, and we're going to multiply those together. So when we FOIL this, we have x times x, which is x times -1, 1.
Isn't there an x squared in there? Never mind, it was right there. X squared.
All right, so x times x.
X squared. -5x. 5x. 25. -25.
All right, so simplify. What happens to our negative x and positive x? And our -5, positive 5?
X squared.
So we have x squared minus 1 and x squared minus, perfect. So now we need to multiply these together because we don't have our whole polynomial.
Those are only 3 steps.
So now x squared times x squared. X squared times -25. -1 times x squared. And -1 times -25. Combining like terms. All right, so this is our 4th degree polynomial, so it meets our requirements. That has these 4 zeros. All right, questions there? All right, so now example 3, we're going to do the same thing, except those all have real roots. Now we're going to look at what happens when you have imaginary in there. Same process, but now we're dealing with I. And the thing to remember is i's get grouped together, but what's important about I squared?
-1.
-1, yeah.
Oh, no.
I times I is -1. All right, so let's read through the steps. So step 1, we use the complex conjugate root theorem to find all zeros. So if we have a 0 at 3, and if we have a 0 at 4i, in order to get an I, we have to square root a negative number, right? And when you square root, how many answers do you get? 2. So if 4i is a root, then guess what else is a root? -4i. So it's a 3rd degree polynomial. We're only given 2 zeros, but if 4i is a 0, then -4i also has to be a 0. So now we have our 3 roots. they're equal to 0, so I'm putting them in parentheses. We have x minus 3, x minus 4i, x plus 4i. Then we are multiplying our binomials together. So x minus 4i times x plus 4i is x squared plus 16. And we multiply that to x minus 3. It gives us this. So this polynomial here has it's a degree of 3, and it has the roots at 3, 4i, and negative 4i. So you guys want to do one together?
Please, sure.
All right.
I have no idea.
All right. So let's look at. Let's do A. We'll do baby steps. All right. So this one, n is 3, but we only have 2 roots given. We have one at negative 2 and one at 3i. So what's the other root that we know? Negative. If this is a root, if positive 3i is a root, then x also has a root at negative 3i. All right, so setting our first root equal to 0, so moving that negative 2 over, what would this parenthesis be? And then what would this parenthesis be? And what would this parenthesis be? The nice thing with the imaginary numbers, because these are the same but opposite signs, the middle term's going to disappear. So let's FOIL these. I'll bring my x plus 2 down. So x times x is x times 3i is negative 3i times x. And negative 3i times positive 3i. What's negative 3 times positive 3? And I times
I squared, which makes
negative 1, which makes that positive, right? Now what happens to my positive 3ix and my negative 3ix?
They cancel. They cancel.
X squared plus 2, 9.
Alright, so now we're going to multiply these. So x times x squared.
That's to the turn.
X times 9.
9x.
2 times x squared.
2x squared.
And 2 times 9.
25.
Alright. So just I'm going to put this in standard form. So I want to start with my highest power and work down. So this polynomial has the roots of negative 2, 3i, and negative 3i.
That's great.
That's great.
All right. So for homework, 13, 14, 15, and then 16 and 17. So 13 through 17.